Okay, so I'm going to do another, this is a full series RLC. So we have a lamp, a coil, and a capacitor. So our R, obviously lamp, L, coil, and C, capacitor. So the information on the question was given to us. So we have our line voltage of 120.62, our line current, our power total, the voltage across the lamp, the voltage across capacitor, and we have an overall lagging power factor. So this current is lagging. It wants to know what's the reactive power of the coil. Okay, so I would set this up again with our sections. I got my lamp, my coil, my capacitor, and my total. We're going to add all these together and get our total values. So my lamp again is just the in-phase component, so it's just going to be a straight line. Our coil is going to be a triangle because it has an in-phase and 90-degree out-of-phase component. And then my capacitor is just going to be a 90-degree out-of-phase component because it has no resistive portion to it at all. And then we have our total triangle, and we can start filling in some information. So again, work in the sections that you need to. Hasn't really given us any ohmic value, so I probably won't be filling anything out here, but I just like to draw it the same every time. So my voltage across the lamp is going to go right here, 47.63 volts. Again, voltage section, so this section, and under my lamp. Then the voltage of the capacitor was 75.3 volts. My current, I'm just going to write down here, I is equal to 2.45 amps, and that's a lag. And it's also giving me my source voltage, so that's going to be my total voltage. So my total voltage triangle, and I'm going to go 120.62 volts right here. And then it gives me the power total. So again, total section, but the power line, so right here, power, but total. And my watts goes down here, so I'm going to put 182.93 watts down here at the bottom. So it's looking for the reactive power of the coil. So it's in the power section, the reactive power, the VARs, right here, of the coil. Okay, so of the coil part. So it wants to know what this is right here. Not the reactive power of the total circuit, that's this one, and this would be the reactive power of the capacitor. Okay, so we're going to start filling out a triangle section in order to fill out all these values. Luckily, they've given us current, so we can kind of move, at least we can move through quickly with that. So pick a section to work in. We're definitely going to have to complete this triangle in some section in order to find out what these values of this coil are. So first off, what I'm going to do is move everything up into this voltage section. So if I take 182 here divided by my current, then I'm going to get the total resistive volt drop of the circuit. So if I get 182.93 divided by 2.45, and I get 74.665 volts here. Now I know that this resistive volt drop plus this resistive volt drop equals this one. So what I can do is take this minus this volt drop, and I'll have that. So if I take that 74.665 minus 47.63, and I get 27.035 volts. Okay, so I'm already kind of in business here. I got one section of the coil. I need to know what this is though, so I can multiply by current, and then I'd have this answer right here. So I got to find out what this reactive portion is. In order to do that, I'm going to have to find out the total reactive volt drop of the circuit. So I'm going to use Pythagorean theorem, go 120.62 squared minus 74.665 squared. Take square root, and I get 94.733 volts. So what's important here now is I need to find out this value here, and I know that this volt drop and this volt drop are 180 degrees apart on the phasor diagram, so they cancel each other out. So that tells me that if this circuit current is a lag, it tells me that this value had to be larger than this one. Okay, because that's how we got into a lag, was the inductive portion of this volt drop being larger than the capacitive volt drop here, okay, the reactive portion of the capacitor. So what I can do to find this then is simply just take this value and add it to this. So if I take 94.733 plus 75.3, I get 170.033 volts. Which kind of, when I double check, makes sense. I got 170 volt drop here, I got 75 here, and when I subtract the two, this is what I'm left with. And it's due to a lag because this is larger than the capacitor volt drop. So I don't really need to fill out any of these other values. All I can do now is take this value, times it by current, and I'll have the reactive portion of the coil, the VARs. So if I take that 170 volts times 2.45, I get 416.58 VARs. So that should be the answer that you're looking for. Okay, so had to do a couple steps there. We had to have an understanding that these guys are 180 degrees apart on the phasor diagram, so they do cancel each other out. We needed to know that this was a lag. It was important, it was imperative for us to know that, so that we knew how to treat this value and this value in order to get that one. Okay, so if you have any other questions, let me know, and hopefully that helps.